I recently came across this cool algorithm for doing inverse kinematics called FABRIK. It stands for Forwards and Backwards Reaching Inverse Kinematics. And it's a really cool way to do inverse kinematics. It's very simple, actually. Here's how it works. So if you have an armature, and our armature is just a series of randomly initialized vectors arranged tip to tail, like so. And we want to get this armature to touch this green target over here. So how the algorithm works is for each link, starting from the end, it's going to put the base of the link at the target and then point that back to where it just came from, like this. So it does that. And then for the next one, it's going to do the same thing, and it's going to put the base of this vector here and then point it back to where it came from, like that. And then it just keeps doing that for each link until boom. So you can already kind of see, like, you can say we're done, but it actually does 2 passes each time in the algorithm. It goes forwards and backwards. So going backwards, we run the same algorithm, and to do that, you just treat this as the target and this as the base. So this is kind of just going to end up look like all of these flipping, which is fine because it pretty much got it on the first pass. All right, let's look at it one more. So here's our random armature. Let's run it. So that points there, there, there. Look at that. Isn't that cool? So it's that simple, and there's no... The thing that's interesting about this is there's not a lot of... There's like no transforms, because it's just points. It's just vectors. So you don't need matrix transforms to do this, and you don't need trigonometry to calculate the angles, because you're not calculating the angles and the joints and everything. You're really just putting vectors together. But the results are cool because they give you this pretty natural looking motion. It's really good for like hands and legs of this spider. So I created this spider using the FABRIK algorithm, and this is a little bit of procedural animation. So it has 8 legs, and each one is its own armature, so it has its own target, and they all share a common base, which is the center of the spider. I love this. I think it's really cool. So let's look at this. How this works is it's just the foot target moves. So if the position of the foot is too far away from the center of the body, it'll jump it back. And this is basically just controlling your feet targets, and then the feet targets move and the IK responds. So that's just how that works. And then I made this little humanoid style rig. It's pretty neat. One of the issues with this is fully unconstrained. So at the moment there are no pull targets. So if I want to move the legs around, they move in a very unnatural way. The knee and the hip is able to just bend 360. So there's ways to add constraints to this, and that would be my next step in this project, would be to add constraints to try to get, you know, more control of this rig. I think I'm starting to find that like rigs, I mean, this should be obvious, but rigs are complicated. Like there's a lot of information that needs to be encapsulated in a rig, and there's not really a simple way to do it. Like there's no way of getting around the fact that you're going to have a lot of different controls for different things and different scenarios. But it's cool. FABRIK, it's a cool algorithm. Yeah, just wanted to share this and explain how this worked. This took me a decent amount of time to make this, but I wanted to make this visual to show how the algorithm works. So hopefully it's clear at a glance now kind of how this works. Implementing it, maybe not as straightforward, but it's still simpler, I think, than the CCD algorithm. I want to do a video on that as well, but that one is, I think, a little bit more complicated because it does require matrix transforms. So maybe in the next video I'll do that, which is another inverse kinematics heuristic. All right, that's pretty much it. Let me know if you want to see anything specific with this or have any specific questions. The code will be in the comments. Thanks for watching.